Last section for the exam. Yay! So today we're doing section 6.3. Again, this one's fairly short. It just introduces a new way to solve trig problems. So in this section, we're learning how to solve problems like this without using the double or half angle formulas. Okay, in the last section we used double and half angle formulas and we got our answer, but here we're not going to be doing that. So to start, in 6.1 we had solutions where on the inside, for instance, we had things like sine of theta plus 3 or something like that. And the way we solved it was you found your reference angle, and then all you did was you subtracted h from both sides. Now, if you subtract from the entire side, okay, subtraction can just move around. So really, we have the solution minus h, and then the plus 360k is on the outside. And so that's what you did. We just subtracted the h from the solution, but the 360k still stayed the same. Now in 6.3, we're going to do the exact same thing, except now we're using it with division. But here, if I divide by a, I still have to divide the entire side by a. Just like in 6.1, I subtracted the entire side by h. And so here the a's would cancel. But notice when you're dividing, you have to divide each term. So we end up with the solution over a plus 360k over a. And so this is the big difference in this section, is that before the 360k stayed the same, but here it's going to change. It's going to divide by whatever our multiplier is. So let's look at our first problem. So I want to solve this both ways, just to show you the difference from the last section to this section. So in the last section, we solved a problem like this. We would use the double angle identity. And it's perfectly valid. Like on the test, if you solved it this way, you would get no points off. So double angle identity. And so the one I'm going to use, you can use sine or cosine, it doesn't matter. I'm going to use the cosine one. The definition for cosine 2 theta is 2 cosine squared theta minus 1 is equal to square root of 3 over 2. So I turned cosine of 2 theta into its equivalent form, and now I just got to isolate my answer. So I'm going to add 1. And so I have 2 cosine squared theta is equal to square root of 3 over 2. Now 1 is the same thing as 2 over 2. I'm going to try to get it as one fraction. And so now I'm just kind of simplifying a bit. 2 cosine squared theta is square root of 3 plus 2 over 2. And then I divide by 2. Well, rather than say divide by 2, I'm going to multiply it by a half. So you can see immediately what happens to that. So I have cosine squared theta equals square root of 3 plus 2 over 4. And we're almost done. So notice that this way it's doable. It's just a lot of algebra is involved. So the next step we would do is we would take the square root of both sides. But whenever we take a square root, we have to add a plus or minus. And so you get this nasty looking number over 4. And with that, we can try to figure out our answer. Now, I'm going to try to swing up here. So we have cosine theta equals plus or minus the square root of square root of 3 plus 2. And then the square root of 4 is just 2. So we could use the inverse cosine to figure out what our reference angles are. So theta If I do the inverse cosine of this, notice that the answer that I get is actually not too bad. So remember, if I do arc cosine of that, and here it's going to be the plus or minus, so I'm going to be using pretty much all the quadrants. I guess I can put the plus or minus here. So, inverse cosine, square root of square root of 3 plus 2, close the square root, make sure I wrote it right, divided by 2, and notice that I get 15. This is in degrees, so before you started, be sure that your calculator is in degrees. So this actually is a nice angle. My reference angle is 15 degrees, but because it was plus or minus, that means that I'm going to be in pretty much every single quadrant. 15 degrees this way, 15 degrees this way, 15 degrees this way, 15 degrees this way. The two on the right are where cosine is positive. The two on the left are where it's negative. But since it was plus or minus, I'd use all of them. And so looking at this, I have 4 solutions. So my solutions, we're only looking for answers between 0 and 360. So if I start here, my first solution I come across is 15 degrees. Then we go this way, and we get to 180 minus 15 is 165. We keep going. The next one is 180 plus 15. That's 195. And then the last one, we keep going, is 360 minus 15 is 345. So we end up with 4 solutions. So a little complicated. A lot of algebra involved, but it was doable. The only way to get the 15 degrees here was to use the inverse cosine function on your calculator. Now I'm going to show how to do the exact same problem, but instead using what we're going to learn in this section. So instead of using a identity, here the identity was we changed cosine of 2 theta into that. Okay. Instead, what we're going to do is I'm just going to find my reference angle right off the bat. So, and it's something that, let me go ahead and write it. I have, sine, cosine, always got to write one out. Okay, so sine starts at 0, then 1/2, then square root of 2 over 2, square root of 3 over 2, and 1, and cosine repeats that. So if I look at this and I just think of it as cosine of a reference angle equals square root of 3 over 2, then my reference angle is 30 degrees. And notice that this is positive. So I have positive 30. Remember, cosine is positive on quadrant 1 and quadrant 4. Have 30 degrees this way. And so my solution is going to be, I'm going to leave it as blank equals 30 degrees plus 360k. And then the other one is blank equals, and then if I start at the beginning and go all the way around, it falls 30 degrees short of a full rotation. So that's 330 degrees. Okay? But here the inside is 2 theta. And so that's what these are equal to. They're not equal to theta, they're equal to 2 theta. And so all I got to do is I have 2 answers. I just got to divide by 2. If I divide the first one by 2, then I get theta by itself. And notice 30 over 2 is 15 degrees, plus 360 over 2 is 180 degrees. If I divide this one by 2, and again, we're dividing everything by 2. I guess I should have written it that way. You don't pick and choose when you divide. You have to divide everything. And so 330 divided by 2 is 165 plus 180k. And if I write my answers out, that means my answers are 15 degrees, 15 plus 180, 195. That's what I get from these. Whereas this one is 165 degrees, and then 165 plus 180 is 345. Notice we get the exact same answer that we got before. Okay, so if we use trig identities, there was a little more math involved. You have to remember that the plus or minus was there, meaning that all quadrants were used, and so we have 4 answers. In this one, I do it like normal, like a regular cosine. It's positive in quadrant 1 and quadrant 4. 30 degrees gives me square root of 3 over 2. So I have 30 plus 360, 330 plus 360, but the angle in question wasn't theta, it was 2 theta. So instead of saying theta equals, we said 2 theta equals, and we divide everything by 2 to get our answers. So that's what this section is all about. It's solving it this way. So let's do a little bit more examples. And yeah, it's actually not too bad of a section. So find all solutions to tangent of 3x equals 1 if x is in radians. So they don't say just the first rotation, so they say all solutions. So looking at this, let's go ahead and find my reference angle. So the inverse tangent of 1 is, we're in radians, pi over 4. And again, you can use your calculator if you want, but it's something that you should know. Oh, wrong one. So you would change your calculator to radians, and then you would do inverse tangent of 1. But then again, that number is kind of hard to use. You have to know that the exact value is pi over 4. Anyway, so that's how we get you to make sure that you know what you're doing and you don't rely too heavily on your calculator. So when we're dealing with tangent, this is a positive one. So I have plus, minus, plus, minus. So tangent is 45 degrees this way, or pi over 4 radians, and pi over 4 radians the other way. Okay. Now with tangent, they're always 180 degrees apart, so you don't need 2 separate answers. So my solution is going to be, put it over here, pi over 4 plus 1, not 180, I keep on, we're in radians, my apologies, pi k. Basically, to go from here to here, it's plus pi. And then plus pi again to go to the other quadrant. But the inside is what we're dealing with. And so I have, my inside is 3x. So instead of theta equals pi over 4 plus pi k, it's 3x. And all we got to do now is divide by 3. And instead of dividing by 3, I'm going to say multiply by 1/3. Because when you're dealing with fractions, that makes life a little easier. So x is equal to pi over 4 times 1/3 plus pi k times 1/3. So x is equal to pi over 12 plus pi k over 3. And there you go. Those are all your answers. If you want, you can keep on writing this so that everything's one fraction. This would be pi plus, let's see, times 4 to have the same denominator. If you wanted to. But you don't have to. All right. And that's pretty much it. Now, if they wanted all the answers in the first quadrant, so if the question, so we're done with the question. But if instead they wanted only the answers in the first quadrant, so only the answers between 0 and 2 pi, what you would do is you would just plug in numbers and keep on plugging in numbers until you get there. So the first answer would be pi over 12, and then you would plug in a 1. And so I'm going to ignore the pi and just think of this as 1/12 plus 1/3, where k is, so this is k equals 0. If k is 1, I have 1/12 plus 1/3. That's 5/12. So we get 5 pi over 12. Okay, and then again, I get that answer plus pi plus 1/3, because all we're doing is adding pi over 3 every time. 3 pi over 4 plus 1/3. Okay, math won that. 13 pi over 12 plus 1/3. 17 pi over 12. I think there's one more, plus 1/3. Okay, and we get 7 pi over 4. All right, so 1, 2, 3, 4, 5, 6, 13, 17, yeah. And so this is k equals 1, k equals 2, k equals 3, equals 4, k equals 5. Anyway, you get your answer. So on the homework, they're going to ask one of two questions. Either they'll ask for the generic answer, in which case it's just this one up here, or they're going to ask for all the answers within one rotation. And in that case, you just plug in values of k until you get to everything between 0 and 2 pi. All right, next one. So here, we're using a trig identity, sine, cosine, cosine, sine. This is actually the formula for sine of 2x plus x. So that's sine of 3x over 2. And looking at our angle here, our reference angle for square root of 2 over 2, we're in radians still, is pi over 4. For sine, plus plus, minus minus. So pi over 4 this way, pi over 4 this way. So my answers, the inside is 3x. So it's going to be 3x is equal to pi over 4 plus 2 pi k. And then the other answer is going to be 3x is equal to 3 pi over 4 plus 2 pi k. And all you got to do is divide by 3, or multiply by 1/3. So x is equal to pi over 12 plus 2 pi k over 3. Here I have x is equal to 3 pi over 12. 3 pi over, oh, the 3's would cancel, so you get just pi over 4 plus 2 pi k over 3. And so there's your solutions. Right? If you wanted to just plug numbers in, then you can. So if k equals 0, meaning that if I plug 0 in for k, I end up with just pi over 12, and then the other answer would be pi over 4. If I plugged a 1 in, I already did this ahead of time, we would get 3 pi over 4. I'll just write it out. 9 pi over 12, 11 pi over 12, which that could simplify. And then if you plug in 2, you get 17 pi over 12. If you plug in 2 into the other one, you get 19 pi over 12. And so that's what you would get if you wanted to list them out. All the answers between 0 and 2 pi. All right. 2 more. Pretty short section. This next one, notice that it's a quadratic, and being really happy with this one, it's actually factorable. So here this is 2 sine of 3 theta, sine of 3 theta. I have a 1 and a 1. And so 2 sine 3 theta times sine 3 theta, that's the first one. I need to do minus 2 plus 1 in order to get the minus sign. So this needs to be minus, this needs to be plus. So 2 sine of 3 theta plus 1 equals 0. Sine of 3 theta minus 1 equals 0. Sine of 3 theta equals negative half. Sine of 3 theta equals 1. All right, so let's go ahead and look at our answers here. So sine is 1/2 at, are we in degrees? Yeah, degrees. 30 degrees. So it's going to be 30 degrees this way, because it's negative. 30 degrees this way. Where the other one is 1. And where does sine equal 1? That's the y value equal 1. And so that is just 90 degrees. All right. So as far as angles go, this first angle is going to be 180, 210 plus 360k. You know what, I'm just going to write the angles here. I'll do the actual math on the other side. So this first angle, no. Okay, so this first angle is 210. And then the smaller angle, this angle here is 360 minus 30, so that's 330 degrees. So those are my two angles for sine, whereas here it's just 90. So as far as answers go, the inside is 3 theta. So it's going to be 3 theta equals 210 plus 360k. I can divide everything by 3. So that's 70 degrees plus, and then that's 120. So that's my first answer. I go on to the next angle. 3 theta is equal to 330 degrees plus 360K. I divide by 3. This is 110 degrees plus 120K. Second answer. And then the last one is 3 theta equals 90 degrees plus 360K. If I divide by 3, I get 30 degrees plus 120K. And so those are my 3 solutions. All right. I wanted to show you on Desmos how this one works. Desmos. So I have 2 sine squared of 3x minus sine of 3x minus 1. And I'm looking at degrees, so I need to go between right. And so look at our angles. This is a weird looking graph, but notice the first x-intercept is 30, 150. So this pattern is separated by 120 degrees. Then you have 70 and 110. 30, 70, 110, and then it repeats, and they're all separated by 120 degrees. And so we got the right answer. 30, 70, 110. All right, let's do this last problem. Then I'll let you go. So this last one is one that we actually did in the last section. Before I added cosine to the other side and I squared both sides. But now that we know about how to solve sine of and then 2x, 3x, 4x, 5x, stuff like that, I can instead square both sides right off the bat. Now I'm squaring both sides. And if we remember from last time, whenever we do that, that means that I have to check my solutions. Okay? So if I square both sides, I end up with sine theta minus cosine theta, sine theta minus cosine theta is equal to 1. And we FOIL it out, so I get sine squared theta minus 2 sine theta cosine theta plus cosine squared theta equals 1. I'm rearranging things because I want to use trig identities. So here I have sine theta cosine theta. Well, that's just a 1. Which I can subtract from each side. And so now I have negative 2 sine theta cosine theta equals 0. But 2 sine theta cosine, or let me divide by the negative, multiply both sides by negative 1. But 2 sine theta cosine theta is just sine of 2 theta. So I had a little bit of algebra involved, a little bit of trig substitutions, making things work, but we actually have our answer. And when does sine equal 0? Well, sine is the y value. My y value is 0 here and here. So 0 degrees, 180 degrees, back to 0 degrees. Okay, so my solution is going to be the inside 2 theta is equal to, we're starting at 0 plus 180k. But I divide by 2. And if I divide by 2, I still get 0 degrees plus 90k. So if we're looking for answers within one rotation, that means my solution should be, and this kind of works out rather nice, the solutions would be 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Remember, we don't include the 360. It's up to 360. So 0, 90, 180, 270. But then we have to check our answers. And I want to graph this on Desmos just to show you. So if I go here and do sine x minus cosine x, okay, and then I have 1, y equals 1. Notice that the graph only touches twice within the first rotation from 0 to 360. So these are my only two answers, 90 and 180. What happened was we squared it. And look what happens when you square it. I'm going to write it twice. Okay. So when I squared it, notice that this answer has 1, 2, 3, 4 answers to it. But that wasn't my original problem. My original problem was sine x minus cosine x. Now the original problem only had these two. So that means that I have to drop 0 degrees as an answer and 270. And so my only solutions are 90 and 180. All right, and that's it for today. I gave you all Friday for more study time. I'm going to be posting a review in a bit, but our exam is going to be next Monday. So if you have any questions, let me know. But y'all got this. Woo! Semester is almost over, guys.